Hi, everyone. So first of all, before I start, I'd just like to thank the CoreOS team for inviting me to talk here today. I'm so excited to be here. Yeah, so my name is Reilly. I work for CA Technologies out of our Boston office. I'm an engineering lead for the CA single sign-on product, formerly known as SiteMinder. I'm also across our directory technology. And previously, I was an engineering lead for our identity management and governance solution. So I guess you could say security is my thing. I'm here today to talk to you about how Kubernetes and containers can simplify enterprise deployments. So a little bit of an agenda. I'm going to give you my viewpoint of where I see containers in its adoption lifecycle in the enterprise. I'll talk through some of the enterprise deployment challenges that our customers and us as a software vendor face. I'll talk about what I see as the enterprise deployment vision using Kubernetes and containers to address those challenges. I'll then talk through how within CA, within our development processes and how we intend to release our software to our customers, how we're using Kubernetes and containers to address those challenges. And then, if time permits, I'll give you a very brief demo of some of the work we've done so far. So let me start off with a bit of history, if I may. And I'm going to show, I guess, my age and how long I've been in the IT industry. Can I ask for a show of hands of anybody who used to use Semantic Ghost as a tool or utility? Okay, great. I thought I might be the only one. So for those who don't know, Semantic Ghost back in the late 90s, early 2000s was a great tool in our software development processes because it allowed us to revert back an operating system, a physical machine, to a known given state. So we were able to provide developers with a given environment that they could develop against. And especially from a QA perspective, when we typically had separate QA teams and we weren't doing Agile Scrum, they were able to go back to the same environments, snapshot, and it really sped up our development cycles. Then going forward to around 2005, even though virtualization technologies have been around probably for a couple of decades, it was really with the advent of VMware ESX that it became more mainstream. So software development teams like I was involved with embraced VMware ESX, similar to the use of Semantic Ghost, allowed us to create templates, push them out to our developers, able to snapshot environments, and as a productivity boon. But it also helped us to reduce our cost. So instead of having all these physical machines, it reduced our cost, obviously. At that time in 2005, our customer base, they also embraced VMware ESX for similar reasons, for reducing cost in their developments and UAT environments. But in 2005, I don't think any of our customers anyway would trust any production workloads on VMware ESX. There would have been questions around security, scalability, fault tolerance, for example. Go forward a number of years to probably late 2008, sometime 2009, we had our customers coming to us as a software vendor saying, you must certify and you must support your products running on VMware ESX in production. I think we're going through a similar journey with container technology in the enterprise. So container technology, I think as most people know, have been around for 10 plus years with Linux LXC and Solaris zones, but it was all too hard for developers to really get their hands on that technology and virtualize applications. Docker, as we know, have come along the last couple of years, provided a really nice REST API, and made it all tangible to developers and all of us to work with containers to containerize our application levels. So, excuse me. So I think that the next step really is from an innovation perspective. I apologize. We've had innovative companies like CoreOS who really pushed the needle, who've been very open and communicative to vendors or customers like ourselves that are just putting our toe in the water, trying to understand what containers will bring for us and for our customers. So I think we're now moving out of an innovation phase to an early adoption phase. And large customers like ourselves, and there was Samsung before, and there was IBM, we're trying to get our heads around what containers can bring for us in terms of our internal development cycles, but also in how we can deliver our software to our customers. So let me move on to what I would see as the enterprise deployment challenges. Well, complexity is inherent in what we do with our customers. We have a large portfolio of products in our security business units, which I'm involved with. We have an identity management product, an identity governance product, advanced authentication, two-factor authentication, single sign-on, directory. And our customers take our software and install it in so many different ways. So we provide product installers that allow our customers so much customization in how they lay down our software. That then introduces challenges around product upgrades for our customer base, but also our support team. And really, the permutations of how our software is laid down and can be used is so vast that it's really impossible for us to, whenever we're doing a software release, to cater for every permutation. It's nigh on impossible. Furthermore, in terms of complexity, our customers lay down our software with a very large machine footprint. So they might be using virtual machines, they may be using physical machines, but they will take one component in our product and apply it to a machine. And they would take another copy of the same component on another machine, and maybe additional ones, and have a replica for high availability and clustering. They would tend to probably have additional capacity on those machines because they've got to cater for, I guess, worst case scenarios or worst case loads on those machines. So there's a lot of wasted RAM, a lot of wasted CPU cycles that our customers have to have in their infrastructure. We have a lot of product integrations. So we're a company that develop organically, but we've also acquired a lot of technology over the years. So that's all got to be integrated seamlessly, and that provides challenges and complexity as well. So all these parts and more mean that we have a very large product support matrix, a number of operating systems, a number of browsers, different versions of operating systems and browsers, databases, LDAP stores, application servers. Very, very large. So complexity is just built in to what we do and what we deliver to our customers. The reality, I believe, is that our customers really want us to provide solutions to their business cases. So if we can find a way to more simply build in our development labs, validate, and provide what we build to our customers and actually have the same thing running in their environments, and make it so easy to install, deploy, and upgrade, then whether our customers are using WebLogic or WebSphere, which is a point that in each of our, we talk to our customers, we've got to support these things. Those things go out the way, and we simplify our offerings to them. And there's a high level of confidence that what we build is going to run in our customers' environments. So what's the vision to address those challenges? Well, I keep on coming back to this, and I've got a couple of colleagues from CA, and they've heard me say this story so many times before. But as consumers of technology these days, what we expect to be able to do is to go to our device, whether a phone or a tablet, we open up a browser, we go to an application store, it provides a nice rich UI, we can search and browse easily. For any application, there'll be a lot of detail about that application. We click a button, it comes down over the internet to our device, and we're running in minutes. So the vision is, can we do the same thing for server-side software? Now, for server-side software, obviously, different from a phone, if I download an app to my phone and it doesn't start or it crashes, generally, who cares? We're talking about mission-critical software on the server side. So the product I'm involved with, single sign-on, we protect websites, and we protect websites for very large customers, very large banks. If our software fails, our customers' banks' websites fail, that means their end users can't log on to their online banking, their end users are losing money, the bank is losing money, losing face, and losing reputation. So the server side has got to be obviously 100% reliable and always available. But that doesn't negate thinking about the server-side infrastructure as essentially that, as a single device. So whether our customers are running in a single data center, they might have virtual machines, physical machines, they might have numerous data centers, they may be running in a cloud service such as AWS with our software, virtual or physical machines, or they may be running a hybrid approach, either the cloud with their own data center. The vision is to see all those machines, virtual, physical, as one device, where that device provides us high availability, scalability, redundancy. So one of the challenges we have from an application development perspective is that we have to build in, or our developers have to think about high availability and failover. So we have our one component installed on this machine with a particular name, and this machine has got a particular name. Our components need to know about those other machines. And if one of those machines goes down in our customer's environment, it's a major thing. It's this sort of the notion of pets and having to carefully water and nurture and feed the machine. So we want to move to this single compute using a common platform where we trust the common platform to provide all those high availability, scalability, all those good things. And Kubernetes is our vision to do that with our customers. So let me talk in a bit more detail about containers and scale. So I think most people here think about containers as Craig was talking like Google previously, being able to scale thousands of containers like up and down as needed. That's not our reality with our enterprise software. Like typically, not always, but a typical enterprise architecture, a monolithic architecture, if I can call it that, is an end user goes to a browser. The browser is served up with HTML pages from a web server. The web server talks to an application server. Could be WebSphere, WebLogic, JBoss, whatever that may be. As a software vendor, that's where we tend to put all our logic. All our business functionality is added as WAR files or WAR files, maybe built into an EAR file. But there's a lot of code at that level. And then the application server will typically talk to a database or LDAP server, or maybe both. And how we scale, as I just mentioned, we basically build components on a server with a particular name of a server, another server, built into a cluster. And each of those machines need to be aware of the state of the other in general. And if one of those machines goes down, it's a major thing. When we talk about containers, we think about microservices, these small pieces of functionality, start up quickly, they can die, go away, have a nice API. And just talking about sort of scaling those microservices, I copied the diagram from the internet showing this cube, where the bottom left-hand axis is 0 scale, and the top right-hand is infinite scale, and there's 3 axes. So talking through each of those 3 axes and how I guess microservices, talking about the internet, would be scaled using those three axes, I guess, and how that applied to our enterprise applications. X-axis, horizontal duplication. So essentially taking like a unit of your application stack, so that makes sense. So in the Kubernetes terms, it would be a pod. So we've taken our application stacks and broken down into Docker images, And when we run them within Kubernetes, they'll run as maybe a number of containers in the same pods, which makes sense for us in terms of scaling. But the scaling would be, you can run as many instances of those pods as you desire, with the traffic coming in via a load balancer. And the load balancer will be aware of any additional pods or nodes that you add to your system. For enterprise application, that scaling is something that we can do. It's not rocket science to take our monolithic architecture and apply that level of scaling. And we've done that with a number of our products. The key thing there is to make sure you're stateless so that you can add additional instances and scale up and scale down as required. That's going to be a big win for us with our customer base. So I'll just give you a brief example of why that's so important to us. The single sign-on project I'm involved with, protecting customers' websites, and it's really all about authentication and authorization. So a lot of our customers will have peak times. It might be like in the employee use case, it'll be first time in the morning, maybe after lunchtime. But more in the consumer world, where we have many, many more users, like millions of users hitting our customers' websites, there'll be things such as an English Premier League football game where people go to a service provider and they want to subscribe or log on to their service to be able to watch the game on their phone. So that's the ability to scale up and burst and then come back down again is important, especially if a service provider is using cloud hosting, because there's obviously cost involved in how many machines or nodes they deploy. The y-axis is what you, I guess, probably think about microservices, the ability to take a small piece of functionality, build it into a container, a nice API, and run it in isolation. So an example of a use case for that would be, in our architecture, we have our identity management product and our single sign-on product. They both have a password services capability. From the external user, essentially the same. They work the same, two different products, two different pieces of code. What we want to do is to take that code, build it into a microservice, into a container, put a nice API around it, and have our two products called into that microservice. That's somewhere on our horizon, that's on our roadmap, but we're not there yet. But not doing that work doesn't negate us from forging ahead on this journey with the container technology. The Z-axis is, I guess, more of an advanced topic around caching of data and indexing data and having sort of subsets of data. That's so far out of our scope that we haven't even thought about that or considered that. But just looking at the x-axis is a big win for us to be able to scale up and scale down our products. So to give you an example of the size or like the volume that we're working with, and we're not working with microservices, let me just move over to our CoreOS Enterprise Registry. And I'll show you an example. This is our identity management and access government products, which is probably our largest product in our security suite. And we've broken it down to 6 components, 6 Docker images. And if I just go to one of those images, which is it's called our connector server, you can see the size of the Docker image we've got is almost half a gig. That's nowhere near a microservice. But for us, this is a great outcome, a great win, because when our customers pull down that Docker image as part of the identity suite solution or identity management solution, it might take the customer a minute to download that Docker image from our registry, which is up on AWS. It may take 2 minutes, it may take 5 minutes. But that's a much bigger win than taking our product installers at the moment and our customers laying down the connector server components in so many different ways and so many different like operating systems, etc. So this is, even though it's not a microservice, for our use cases and our customers, this is going to be a major win. So let me talk about how we're getting to this vision. We're using a cloud-hosted DevOps approach. So internally in how we do our development, we're not quite yet at the level of maturity that I would like, but the idea would be using GitHub, using Jenkins. When we commit, then we obviously automate with Jenkins and push to Docker registries, and it all gets automated. We're working towards that internally at the moment. But for our release part of that DevOps approach, we're using AWS infrastructure. We're using the CoreOS Enterprise Registry. We get each of our product teams to containerize their product stacks using Docker. Now, we went with Docker a long time ago, before Rockets it came to the fore. And maybe that we change over time. We may go to Rockets, and especially when we start working more closely with some of our customers, because we work with large customers, large banks, and security is of high concern to them. So whether it's Rockets or Docker, we're very open to the idea, but we've gone with Docker at this moment in time. We get each of the product teams then push for each release of their software, the Docker images to the CoreOS Enterprise Registry up on AWS. Each product team creates a Kubernetes solution manifest, or maybe manifest files, that provides essentially best practice for how they want their customers to deploy their software, and also to provide an example of how that runs as well. And as we've learned so much from the good people at CoreOS, and I'll just take a little bit of a tangent here, if I may. CoreOS have been great to us in terms of working with them, and I think it was Richard from Samsung mentioned much the same. And Joey Shaw, if you're there in the audience somewhere, thanks very much for all the help you've given us over a long time period. You guys are so open and being so helpful to us. We really appreciate it. So we're trying to do the same with our customer base. We're providing an early access program to all our customers where we essentially provide a ready-to-go Kubernetes cluster, which is a CoreOS master, a CoreOS node, or however many nodes the customer wants to run. They can download that Kubernetes cluster from our support site to their local environment, start the Kubernetes cluster up in VMware ESX, even VMware Workstation or VirtualBox on their local machines. And once the cluster starts up, we pull down some default Docker images from our CoreOS Enterprise Registry that provides an App Store type interface for our customers to our security solutions. And then our customers can browse the App Store, click a button, and deploy our solutions. So in a bit more detail, we're using 4 AWS regions: North California, US West, North California, US East, Virginia, EMEA is Ireland, APJ is Singapore. We use EC2 instances in each of those locations. We've deployed and configured the CoreOS Enterprise Registry in each of those locations. As I mentioned, our product teams push the Docker images up to the CoreOS Enterprise Registry. We use S3 buckets to store the Docker images. Now, the Enterprise Registry supports S3, I think Google Compute Storage, Ceph, or local disk, and I'm sure probably more. And then we replicate those Docker images across the 4 regions. Now, at this moment in time, we're using basically the AWS client to do S3 replication between the regions. And there's a latency of around 10 minutes. That's OK. But that hasn't caused us any problems at this point in time. But another example of working with the CoreOS team, we reached out to Joey Shaw and the team, or my colleague up there, Tim Hobbs, did, to say, is there any way that you can help us address this problem natively within the Enterprise Registry? Within a short time frame, the CoreOS team came back to us with a solution. We haven't tested that solution yet, and we apologize. We haven't come back to you guys with the information, but we will do in the coming weeks. But it's great that that sort of community spirit, and for us to be part of that is really refreshing for us. So moving over to the container orchestration part, why did we go with Kubernetes? We could have went with Docker Swarm, for example, or other choices. We went with Kubernetes because of the reputation from Google running at scale. The likes of CoreOS were big advocates of Kubernetes. We knew that Red Hat, with their OpenShift technology, was moving to Kubernetes and Docker with their version 3 of OpenShift. But the main thing is that we know it runs anywhere. So whether it's cloud platforms such as AWS, Azure, I think as Craig mentioned, it'll run straight away in the Google Cloud Platform. Kubernetes is just ready to go there. DigitalOcean, OpenShift Online, Rackspace, you can configure Kubernetes in any of those environments. If our customers want to get the maximum performance or speed, they can deploy on Reilly, CoreOS, Ubuntu, CentOS. A lot of our customers will be invested in VMware ESX, and they're not going to give up that investment lightly. So I believe VMware are looking to support containers and Kubernetes as well. But I would hope or expect that over time, a number of our customer base will look to embrace enterprise platforms. So if they're running containers, hopefully the likes of Tectonic will become more prevalent in those environments. Maybe OpenShift as well, or maybe the likes of MessageSphere with the Kubernetes package applied to it instead of Marathon. So let me touch about our early access program. So our customers can go to our website with a defined URL. They authenticate with their CA support credentials. They get a web page where they can enter a name of a master machine. They can provide an SSH key if they wish, or we can generate one for them. They click a button, and then we create a master CoreOS OVA file and a Node OVA file. And then the customer can download those OVA files to their environment, start them up in ESX or Workstation or VirtualBox, and then in a very short time frame, in seconds, they'll be presented with an App Store interface if they go to port 80 on any of the machines. They can browse our catalog of solutions, click on a button, deploy the solution. The solution comes down over Docker images from our registry and runs in the customer's Kubernetes environment. So just let me give you a quick demo of that, if I may. So this is a Kubernetes cluster that we got running in a small cluster. Our customers can just click on, say, deploy of an application or solution, accept the EULA. Now, obviously, data and configuration has got to be stored separately than the running binaries, if you like, the Docker images. So we've got a implementation pattern, a design pattern, where our product configuration is stored externally. We're using GitHub in general, but it's basically any web server with a URL that points to a zip file with the customer's configuration zipped up. Once the pods or containers start up, the solution starts up, that zip file will be copied locally to a sidecar container, the contents of the zip file extracted, and then the configuration gets copied into the container before it starts servicing requests. So that allows a number of benefits. Obviously, the separation of configuration from the running binaries, but also to have a version control of our configuration, which is something that many of our customers have been asking for. So if I just click on deploy now, this then goes up to our CoreOS enterprise registry, and it will start to pull down the Docker images for our CA directory solution. And you can see there are our containers that are starting up. While it's happening, I'll just move to our largest product. Our Identity Suite product is a large number of components. And it takes maybe, it may take about 15 to 20 minutes to download this solution. Now, that's a massive win for us to be able to do that for our customers. So for our customers to be able to say, I want to deploy or upgrade to the latest Identity Suite solution, and it takes them 20 minutes. Our customers are so excited for us to be hearing this. These Docker images, they're not microservices, they're quite large, as I say. So containers and Kubernetes, to us, seems like a perfect fit to help us address the types of challenges that we face for our customers. So on that note, I'm not sure I'm running over time. That's the end of my talk, so thanks for your time. Thank you.